In this video, we'll be analyzing quadratic functions in factored form. This is also known as intercept form. So we'll be looking for equations that possibly have a greatest common factor on the outside, which will relate to the a value, multiplied by the two factors in the form of x minus blank times x minus blank. And with this, we'll be able to find the x-intercepts, line of symmetry, the vertex, determine if it's a max or a min, and do a quick sketch of the graph. Our first example, we have y equals x plus 2 times quantity x minus 10. And if we just match this up with our fill-in-the-blank strategy, we see that our a value appears to be missing. So when it's not there, we can use a 1 to hold the spot. So we know that a is equal to 1. And then we're going to take our two factors and set each of those equal to 0. And this will solve for the x-intercepts. So we'll have x equals negative 2 and x equals positive 10. We'll go over and just approximate that on the graphs. Negative 2, positive 10 could be about there. And the fact that a is 1, it's more important that a is positive 1. This means we're going to have something that's concave up, so our vertex is going to be a minimum. Our line of symmetry is the halfway point between the negative 2 and the 10. So imagine it as the fold line. So to find the line of symmetry, which I'll abbreviate L/S, we're just going to take our two x-intercepts, negative 2 and 10, add them and divide by 2. It will always be the average. So we'll get 8 over 2, which is 4. So our line of symmetry is x equals 4. I'll label that up here. To find the vertex, we need to find the y value. We know the x value is x equals 4 because the vertex always lies on the line of symmetry. So we only need to substitute that x equals 4 into the equation. Remember, our equation is y equals, and we have whatever x plus 2, whichever x value minus 10. And in our case, we're concerned with substituting the 4 in. And you'll notice we get 6 times negative 6. And it's not a coincidence that we have opposite values, because that really tells me that I go 6 in the right direction, 6 in the left direction in terms of the line of symmetry. So our y value of the vertex is negative 36. This tells us that our vertex is located at 4, negative 36, which I'll just approximate down here someplace. We're not really concerned with the y scale at this point, and we can sketch our parabola. Okay, our second example. In this case, we're going to notice that the a value, which I'll just identify here, a is negative 2. So this tells us we're going to be concave down, or our vertex is going to be a maximum. Our x-intercepts are the easiest thing to find. We set each factor equal to 0. So we have x equals 1 for the first factor, and then x minus 15 equals 0. So we have x equals positive 15 for the second. And again, we're just going to approximate those on the graph and put in some numbers to hold the spot. Our line of symmetry, again, it's just the average of the two x-intercepts. So the x value of the line of symmetry, which we can also refer to as h from vertex form, is the 1 plus 15 divided by 2, 16 over 2, which is 8. Again, we can sketch that in here. This will be our fold line. So we have x equals 8. So again, we're going to look for the y value of the vertex, and we'll use our equation. So we have y is equal to negative 2, our x value minus 1, our x value minus 15, and in this case, our x value was 8. So we will have negative 2 times 7 times negative 7. Again, notice we have opposite 7 and negative 7. So this will give us a value of positive 98. So our vertex will be located at 8, 98. And again, we're just going to approximate that y value up here. And if we mark it down 8, 98, we should be fine. And we'll sketch our parabola. And if we needed more values, we can always substitute in and make a table of values, or substitute 0 to get the y-intercept. Our third example looks a little strange to many people, but it's actually fairly straightforward. Again, our a value, negative 16, tells us it's concave down, so we'll have a maximum. And we don't clearly see the factors sometimes. This x is not adding or subtracting anything. So this is what actually makes it easier. It's x equals 0. And in our second piece, we have x minus 10 equals 0, something we're used to, so we have x equals 10. So again, just plotting those points, we do have 0, and we can approximate the 10, and we know the line of symmetry is going to be halfway. Probably don't even need to do the math for this one, but we will. So our x value will be 0 plus 10 divided by 2, 10 over 2, which is 5. So we'll have x equals 5. Now we just need to find that y value for our vertex. So we're going to substitute that in. So we'll have y equals negative 16 times our x value minus 10. And again, the x value that we're substituting in is 5. So we get negative 16 times positive 5, negative 16 times negative 5. This gives us a value of 25 times 16, and it will be positive. So we're left with 400. So our vertex will be located at 5, 400. Again, we can just label that here, not using a y scale. As long as we label it, we should be okay. For our fourth example, it looks a little strange because it seems as though we have repeated values. We'll first identify a as usual. So a is 1/2, so it's positive, so we'll be concave up with a vertex its minimum. And then notice our two factors are the same. We end up with x minus 8, 0, x minus 8 equals 0. So we have x equals 8, and again, x equals 8 if we want to be repetitive. So the only value to mark on here as of now is 8, and I know it's concave up. This means that the vertex is on the x-axis. We have what's called a double root. We can still go through the same steps. Our line of symmetry is going to be these two values added together divided by 2, and we end up with still 8. So we can put our dotted line here, and then it should be no surprise what the y value of the vertex is going to be. So we're going to find that anyhow. Just so we go through these steps, y equals 1/2 x minus 8. And again, we're going to have x minus 8. We can write that as x minus 8 squared. So we're left with 8 minus 8. So we're left with 1/2 times 0, which of course is 0. So our vertex is going to be 8, 0. So if we really needed another point, we could go ahead and kind of figure out what the y-intercept is if we needed something to be a little more accurate. So if we wanted to find the y-intercept, we're just going to go ahead and do that up here. We'd have y equals 1/2, and we substitute in 0 for x to find the y-intercept, you should remember. So we're going to get 1/2 negative 8 times negative 8. So 8 times 8, 64. Half of that's going to be 32. So our point right here is the y-intercept is 0, 32. Hopefully that clears things up for you and helps you with intercept form, also known as factored form.